Hello and welcome. Today, we're going to dive into a question that sounds super simple on the surface, but is actually incredibly deep. What does it really mean to explain why something happened? We all think we know the answer, right? But the scientific way of looking at it, well, it's much more like a detective story. So let's grab our magnifying glass and get to investigating. Okay, picture this. You see a thread, and it snaps under a weight. If I asked you why it broke, you'd probably say, easy. The weight was too heavy. And look, you're not wrong, but that's not the whole story, not even close. That's just one clue in a much bigger case. A truly rigorous scientific explanation needs a full-blown logical investigation. All right, so the case file is officially open. Our subject? One simple snapped thread. Our mission here is to build a logical case that is so airtight, so completely undeniable that it leaves zero doubt as to why that thread had to break. Now, in any kind of logical detective work, the very first step is to be crystal clear about what you're trying to explain. There's a fancy term for it, the explicandum. It's just the one specific thing that happened. Notice, we're not trying to explain why threads in general break. No, we're explaining why this specific thread right here, right now, will break. It's all about that singular event.
So, to crack this case, we're going to need two totally different kinds of clues. Seriously, think about a detective showing up at a crime scene. They need to know the law. That's the rule book, right? But the rule book is totally useless without the actual facts, the evidence found right there at the scene. You absolutely need both. And this distinction is the key to the whole thing. On one hand, you have your universal laws. That's the rule book. These are statements that are true everywhere for a whole category of things, like the laws of physics. They never change. On the other hand, you had the initial conditions. That's your evidence. The specific one-time-only facts that apply just to our case and nothing else.
All right, we've got our framework, we've got our detective's toolkit. Now, let's actually apply this to our snapping thread. You're about to see how a proper explanation isn't just a good story. It's a chain of pure logic, where the ending is completely inescapable. First up, from our rulebook, we pull out a universal law. We'll call it L1. This is a basic rule of materials science. Any thread that's made a certain way has a specific breaking point, a weight it just can't handle. And this isn't just true for our thread, it's true for every thread of this type anywhere in the universe.
Okay, next, we need to get a little more specific, but it's still a universal law. Let's call it L2. Let's say we've done our homework, we've run the tests, and we know that for this exact type of thread, that breaking point is precisely 1 pound. That's a known physical constant for this stuff.
Okay, rulebook is set. Time to look at the evidence from our actual crime scene. Our first initial condition, we'll call it C1, is simple, but you can't skip it. We have to confirm that the thread right in front of us is, in fact, that specific type of thread with the 1 pound breaking point. We've officially identified our subject.
And here comes the final piece of evidence, C2. The specific weight that was placed on this particular thread was 2 pounds. Now, this is the thing, right? This is that smoking gun fact that most of us would just point to and call the cause. But as you're starting to see, it's just one piece of a much bigger, more elegant, logical puzzle. And here it is, the big aha moment. This is where it all just clicks into place. You take your two universal laws, the general rule and the specific constant. You combine them with your two pieces of evidence, identifying the thread and the weight on it. When you put all four of those premises together, the conclusion, this thread will break, isn't just likely. It's not a good guess. It is logically unavoidable. It has to happen. That is a rock-solid causal explanation.
So, we've built this perfect logical case, right? Seems pretty unshakable. But here's the twist, and it's one of my favorite things about science. It's kind of counterintuitive. Scientists don't actually spend all their time trying to prove their universal laws are right. Instead, they try their absolute hardest to prove they're wrong. This whole process is called falsification, and it's so clever. Think about it. You can never test a universal law in every single possible situation to prove it's 100% true forever. It's impossible. But you only need to find one single time that it fails, just one prediction that doesn't come true, and you know your theory has a flaw. The logic behind this is it's beautiful. It's a classic form of argument called modus tollens, and it goes like this. Step 1, you say, okay, if my theory is true, then this specific thing has to happen. Step 2, you run the experiment, and oops, the thing doesn't happen. Well, what's the only possible conclusion?
Step 3, your theory must be wrong. Now, don't let all the symbols on the screen intimidate you. This is just the formal, logical way of writing down exactly what we just said. It means if your theory, that's T, implies a certain prediction, that's P, and you discover the prediction is false, then the theory itself has to be false. There's just no way around it. It's a logical dead end for that theory. So what's the big picture takeaway here? What does all this tell us about the scientific mindset? It shows that it's not about having some kind of blind faith that your ideas are correct. It's about committing to a process, a procedure, for ruthlessly trying to find out where you might be wrong. You know, you might think science is built on this grand belief that every event in the universe has a neat, tidy explanation waiting to be found. But that's not really it. Science doesn't actually rely on a principle of causality. Its foundation is something much more practical, and honestly, more stubborn. What really drives science is what you could call a methodological rule. It's a decision. It is the core commitment to never give up the search, to never abandon the hunt for those universal laws and for a logical system that hangs together. It's the stubborn refusal to say, we'll never know, that keeps everything moving forward. So the next time you see something happen, anything, a glass of water falls over, a puddle dries up in the sun, and you ask yourself why, try putting on that detective hat. Ask yourself, what are the universal laws at play? And what are the specific initial conditions on the scene? You'll start to see this hidden logical structure in everything around you. It's a really cool way to look at the world.